So welcome to this video. In this video, I will again explain the Dunning-Kruger effect. You remember the Dunning-Kruger effect is the effect that people who think that they are very smart in a certain area very often overestimate their smartness. And we will use the data set Albus Dunning-Kruger here. And we will do that because the Dunning-Kruger effect is very helpful to demonstrate the basic statistical procedures that you need to apply in your project. So let's first have a look at the data set. And whenever you have a data set like this is the data set Albus Dunning-Kruger sample 500. It makes sense in the first step to get an overview over the data to create some frequency tables. So you can see here we have the worksheet data. Here you have the worksheet variables. And if you see at the variables here, all the variables are explained in this data set. So for example, let's say we want to know here we have gender. We want to know how many men and how many women we have in our data set. So that would be our first step to create a frequency table about gender. So I click anywhere into the table, insert a pivot table. And here I want to have a new worksheet. This shows the table. You see here's a frame around the table. So we can just click on OK in this window. And now we have a new worksheet here, table 1, where we can create our frequency table. So our first frequency table we want to create is a frequency table about gender. So I put gender into the rows. And when we create a frequency table, now you see here, we have 1 for males and 2 for females. And when we create a frequency table, we need to take the same variable and to put it into the values. Yeah, and now you see Excel automatically calculates the sum here, and we don't want to have the sum. We want to have the number or the count of men and of women we have in our sample. Yeah, so here we see I think this is already the correct count because okay, let's so to get the count or the number, we have to click on this little triangle where we can open our value field settings. And here we can click on number. Okay, now you see we have 343 males and 298 females in our data set. And it always makes sense also to create a diagram. So let's insert a diagram. We click on insert and then I take recommended diagrams and I can just take the first one. Let's make it a little bit smaller. Okay, and just remember for your report in the diagram there should always be explanatory, which self-explanatory, which consists of 3 basic points. You want to have a heading, so number of males and females. Then you want to have the data in the bars. So with a right click, you can here insert data so that you have the exact data in the bar. And usually you also write a brief explanation here under the diagram. Should be like most participants, we have 343 males in our survey. We have 343 males and 298 females in our sample. Okay, so that is self-explanatory. So it is helpful to get an overview over the data to create some more frequency tables. And I would propose that you pause the video now and maybe you create some more frequency tables about some other variables that you're interested in. Maybe here we have self-placement in the left-right continuum. We have, for example, probability to vote a certain party, or we also have the educational level here. This is ISCET, that is the educational level of our participants. So we also have here different no, these are not income classes, so it would not make sense to create a frequency table from this variable. That you first would have to group these data. But you can take different variables, just have a look at all the variables and take the variables. Here we have overall life satisfaction and create some frequency table. So pause the video for a minute and create some frequency tables. So now the next step, after you have you did get an overview over your data, we want to evaluate the Dunning-Kruger effect, and therefore we have here the question in the column B. I do not know much about politics. We have 1 would mean I strongly agree, and 4 would mean I strongly disagree. So those with the 4 are those who think that they know a lot about politics. And that is the first variable that we need for our Dunning-Kruger effect. And then we need to find out if those who think that they know a lot about politics, if that is really true. And therefore, we have at the end of the data set 8 questions. For example, the question, who elects the chancellor of Germany? And if you want to know what the right answer is, I have here in the variable view, I have the correct answers. So here for the Chancellor of the German Republic, number 3 would be the correct answer. There were different answer possibilities, like as different options, like the people, but in Germany it's the parliament who elects the Chancellor. So, and the parliament was 3, so 3 was the correct answer. Here you see the Richtlinienkompetenz, that is also the chancellor holds the Richtlinienkompetenz. So here 2 was the correct answer. Then who has no seat in the Security Council? There we have different countries, and the correct answer was Japan, and that was the number 2. Then when can EU citizens vote in Germany? Then they could vote in local elections, so 2 was the correct answer here. Then what is the solidarity surcharge used for? It is for German unity used for, and so 2 was here the correct answer. Then how many states do we have in the EU? And this survey is from 2018, when Great Britain still was a member of the EU. So 28 states we have, and 3 was the correct answer. So 3 stands for 28 states. Which party has the most seats? Here we have the parties AfD, FDP and the Green Party, and in the last parliament, not in the actual parliament, but in the last parliament, the AfD had the most seats, and 2 stands for the AfD, so 2 was the correct answer. And the last one is, what is the Dublin regulation about? It is about asylum, and 3 was the correct answer. So what we need to do now in our data view, we need to replace the correct answer with a 1, so 1 point, and all other answers, all incorrect answers, with a 0. So for to do that, the first step would be that we sort our data. Yeah, and this is an important procedure that we very often need to do. We need to calculate or to recode our data and create new variables. So the first step, we want to sort the variable who elects the Chancellor of Germany, and therefore we click on sort and filter, and I always use this custom defined sort. Here we can important that we click here, that we have headings, and because if we don't click here, then he would put also sort our headings, and you will find this heading somewhere in the data set. So here we can tell Excel which variable to sort. So we want to sort the variable who elects the German Chancellor. You can see here that I have already done that. So, but I will do it again to to show how it works for those who still have problems with that. So first we sort our variable who elects the German Chancellor. Then the next step would be, let me just delete this variable. The next step would be to insert a new column. So I insert cells. Now we have a new column here, and I call this column Chancellor N for Chancellor numbers. I could also call it Chancellor 1, 0 because I only want to have ones and zeros here. So now I want to replace all the wrong answers with a 0 and all the correct answers with a 1. So I can -8 stands for I don't know, I think. So I don't know is no 0 points. Now I can go to the corner, yeah, until the mouse changes its form and we have this little cross here, and then a double click and the whole table will be filled in. So we scroll down now, and here we have 1 is still the wrong answer. Let me see again. What was the correct answer? Who elects the Chancellor of the German Republic? 3 was the correct answer. So I go back from the variable view to our data. So I scroll down to 3. Here we have 3. And here I insert a 1. Again, go at the corner, double click. Now I think we also have 4 or 5 as answer options. So let's have a look. Because 4 and 5 should also get 0. Here we have 4. So the rest of the answers will all get 0 points. Double click. And just to test if everything went okay, went fine here, we should only have ones and zeros here in this new variable. Therefore, I could create a new frequency table. So I insert pivot table. Now I don't want to have so many worksheets, so I insert the pivot table in the already existing worksheet. Okay, click into the worksheet and say OK. And now I can take my new variable Chancellor in numbers, put it into the cells and also into the values. And now here we see something went wrong. No, nothing went wrong. We have 399 times the 1, but that is again because Excel automatically calculates the sum. And the sum of no matter how many zeros is always 0. So what we want to have the count again. And then we will see how many correct answers and incorrect answers we have. So we have 399 correct and 242 incorrect answers. Okay, so that's the way to create the new variables. Now your task is also to create the new variables that we have here for the other 7 questions. So as I already said, that is the first question: who elects the Chancellor of the German Republic? Next one is who holds the Richtlinienkompetenz? And there you always can look into the variable view to see what the correct answer is. And then here for the 2's, we want to recode the 2's into a 1 because that is the correct answer. And all other answers should get 0 points. Yeah, and then you have to do it for all 8 variables. And I propose that you pause the video now and do it for all 8 variables. Okay, so if you still have problems, I will repeat it once again for the Richtlinienkompetenz. So first step would be to sort our data, the variable Richtlinienkompetenz. So I take custom defined sort, and here who holds the Richtlinienkompetenz is a variable I want to sort. Here I have to click on data have headings. I can confirm that with OK. Now this data is sorted. Next step, I have to insert new cells. So right click, insert cells, so that I have a new column here. And here I want to have a new variable and I name it Richtlinienkompetenz N for Richtlinienkompetenz in numbers. So I can look into the variable view to see what the correct answer is. The correct answer is 2. So the 2 should become a 1 and all other values should become a 0 points. Yeah, so here -8 is, I think, I don't know. So I make a double click in the corner again. Yeah, go with the mouse in the corner. When it changes its fonts, I can make a double click. Excel automatically recognizes the whole table and fills the whole table in. Now I scroll down. 2 was the correct answer. So I scroll down till I arrive at the 2. That was the 2 stands for the Chancellor, because it's the Chancellor who holds the Richtlinienkompetenz. So that is the correct answer. Here I have to insert a 1. Then again I go into the corner until the mouse changes the form. Now I can make a double click and the rest of the table will be filled in. But we also have values like 3 and 4, and they should also become a 0 and not a 1. So I have to scroll down here and to insert a 0 for the 3. Again, double click, and now for the rest of the cells we should have zeros. We don't have to do that for every variable, but whenever you create new variables, very often it makes sense to get an overview to create a new frequency table about your new variable. So I insert pivot table, again use the same worksheet. Now I have to click into the worksheet where I want to create my pivot table, and I create it here. Okay. Sometimes you don't find the new variables here. If you don't find the new variables, then you have to click on pivot table analysis and then refresh. This button refresh. Yeah, then you will find them. So let's have a look for our new variable. Richtlinienkompetenz N. Here we have here we have Richtlinienkompetenz N. So let's just have an overview. We should, in our frequency table, we should only have 1s and 2s. And here we only have 1s and 0s, sorry. But we still have the sum, so we have to click on count again. Now we see only 168 persons of our sample could give the correct answer for this question. Okay, so now, as I said, if you have not already done that, you should recode the other of the questions, of the 8 questions, so that we always have for the correct answer a 1 and for the incorrect answer a 0. Okay, after you have recoded all these 8 questions, this little quiz about political knowledge, now we need to calculate the number of correct answers question for every participant in our survey. So I create a new variable, I call it correct answers. And now our new variables, they always have n at the ending for numbers. We need to sum them up. So we can click on equals. That is always for Excel means now I have to calculate. Yeah. So equals the first number plus the second new variable, which is here. Let's take, okay. Plus the third new variable, which is here, plus the next new variable, which is here, plus this new variable, plus Security Council, plus Richtlinienkompetenz in numbers, plus the last one, who elects the Chancellor of the German Republic. Then I can click on Enter. the whole formula. You can also enter directly the names of the cells. Yeah, that would also be possible. Okay, now we can again, because we refer to these cells, we can again use the autofill-in function. Yeah, so we just have to double click here in the corner, and then he would not take the 0 to all the other participants, but he would take the formula to all other participants. So I make a double click. Let's now have a look here. For example, here you see he calculates all the numbers in the line of the participant number 10. Yeah. Okay, and enter. So now I have the number of correct answered questions for every participant, and as always I want to have an overview if everything went right. I should get values between 0 and 8. So let's again create a frequency table, insert pivot table, and I will again use the same worksheet. Okay, I need to have a distance of 3. So again, insert pivot table, existing worksheet. So I need to have 3 empty lines here between the table ahead. So now it works. Now let's get an overview. How many people we have in our survey with 8 correct answers, 7 correct answers, or even 0 or only 1 correct answer. So correct answered questions. Here the scale is correct between 0 and 8 because we had 8 questions. Now we take the same variable into the values, but we don't want to have the sum again. We want to have the count. And let's also insert a diagram. Okay, so here we can see now it's close to being normally distributed, yeah, relatively normally distributed. So most have 3 or 4 questions correct, 3 or 4 correct answers. Here we have 8 persons who have 21 persons who could answer all 8 questions correctly, and here we have 29 persons who couldn't answer any questions correctly. So now we want to relate our new variable, the number of correctly answered questions, to the variable I don't know much about politics. We want to see if those who don't know much about politics indeed answer, or if those who said that they know a lot about politics, who strongly disagreed with the statement I don't know much about politics, if those indeed could answer more questions correctly than the others. So the first procedure that we can apply here would be we can calculate the correlation. So our null hypothesis would be there is no positive, the correlation coefficient equals 0. There is no correlation between the self-rating of political knowledge and the number of correct answered questions. And the alternative hypothesis would be there is a positive relationship. Those who rated their political knowledge higher could also answer more questions correctly. So these would be our 2 hypotheses, and now we need to calculate the correlation coefficient. So therefore, to calculate the correlation coefficient, I want to have the 2 variables that I want to correlate into a new worksheet, because I need to have the 2 variables next to each other. So here I first click on the B so that I mark the whole column. Then I can click on Control Z, create a new worksheet by clicking on this plus. Here I can Control V, enter this variable. Then I go back to my data view and I copy the correct answered questions here by clicking here on the AQ. Copy, go back into my table, and then I click on the next column, and here I can I need to insert the values because here we have a formula and he cannot calculate the formula because he don't have the cell references here. So here we have values. We can click on values. So now he entered the values. Okay, now I want to calculate the correlation coefficient. The correlation coefficient is relatively easy. We just need the formula. In English, it's correl with C. Yeah. In German, it's correl with K. And if you have another language, then you need to find out. Yeah, but I think that's not. It's also, you can look for a Google Translator, but I think usually it's not so difficult to find out. So if you open the brackets, wait a moment, I want to have a better view here on the data. So here you see, if you open the brackets, then he shows you the syntax, and he wants to have two matrices. That means a matrix is nothing else than an area with numbers. Yeah. So first, matrix number 1 would be the numbers for I don't know much about politics, and I think you can click into the first cell, and then you have to click on Control. Großschreibtaste. What was the English expression for that? I had Shift, so you can click on Control, Shift, and then the arrow down, and it automatically marks the values up to the end of the table. Yeah. So then you have to. So it's Control, Shift, and then arrow down. So then you have to insert a semicolon. Yeah, and now he wants to have the second matrix. You can also do it in the traditional way. You mark one cell, hold, and then go up. That needs a little bit more time, but it's also okay. Don't mark the heading. We only want to have the matrices, only the numbers. Yeah, you can also insert this value per hand, A2 to A642, semicolon B2 to B642. If these are the correct numbers. Yeah, the letter is always the column here B, and the number is always the row. So now I close the bracket, and you remember that the correlation coefficient is always between plus and minus 1, and a correlation coefficient between plus and minus 1. Correlation coefficient of 0 means no correlation. A correlation coefficient between 0 and 0.3 means a small correlation. Between 0.3 and 0.6, a middle correlation, and higher than 0.6 would be a high correlation. So let's see. Yeah, here we see we have a middle correlation, 0.369. Yeah, so obviously there is a correlation between how people rated their political knowledge and how many questions they could answer correctly. So in the sense that the higher people rated their political knowledge, because 4 was I strongly disagree with the statement, I don't know much about politics. So the higher they rated their political knowledge, the more questions they could answer correctly. So you need to calculate a correlation coefficient in your project, but I'm not exactly sure how to test the correlation coefficient in Excel. It's very easy in SPSS and our other statistical programs, but I don't know exactly how we do that in Excel. So just to remind you, the null hypothesis would be that this difference that we can observe to 0 is just a coincidence, and that it is not, this difference is not significant. Yeah, that would be the null hypothesis. There is no correlation. The correlation coefficient equals 0. And the alternative hypothesis would be that there is a correlation and the correlation coefficient is higher than 0. But I don't know exactly how to test that here in Excel. Maybe I will try to find out. So it's enough to have the correlation coefficient here, and the positive correlation seems not to confirm our Dunning-Kruger bias, because indeed, yeah, we have done that with our first survey. There we had no correlation, I think, or even a negative correlation, but here we have a positive correlation, so that seems not to confirm our Dunning-Kruger effect. But let's see. So now, because we have here 2 times interval scale data, we can also compare the means. So let's say we want to have all our groups is 1, 2, 3, 4, yeah, and we want to have how many questions on average could these 4 groups answer correctly. So we compare the means. Now we take this table. We could also go back into our data set, but we can also take this table here. But you need to have space between the table and the correlation coefficient, because if you have no space here, then Excel would recognize all 3 columns as a table, and we don't want to have that. Okay, so we click here into the table anywhere. Excel automatically recognizes. We create a pivot table, and now we want to have a pivot table in the already existing worksheet, because we want to have the pivot table here, and we already know that we need to leave a space of 3 rows. So here we create our pivot table, and now we take our first variable. I don't know much about politics, into the rows. So now we have here the 1, 2, 3, and 4. 4, as I said, those who strongly disagreed with the statement. I don't know much about politics. 1, those who agreed with that statement. Now we take the second variable, the numbers of correct answered questions, into the values and calculate the average. Yeah, so click on this little triangle, value field settings, and here we have our average. So let's have a look at the result. We can also insert a diagram. Here we have the diagram. In your project report, you should always, whenever possible, use diagrams. We want to have the tables and the diagrams in the research report. So we also insert the data. It's a little bit, now the average, we have a lot of places after the comma. So we can change it by just double click on these numbers, and then we can here change it. We can click on number, and here we change from standard to number, because then we have automatically 2 places after the comma, and that would be enough. Yeah. So here you see again, those who rated the political knowledge the highest could also on average answer the most questions correctly. So again, that seems to contradict our Dunning-Kruger effect. So let's now try the third procedure that is important in basic statistics. That would be to create a cross table. And again, I want to remind you, we have 2 times interval scale data here. Yeah, so scale from 1 to 4 for the political knowledge, and then a scale between 0 and 8 for the correctly answered questions. So because we have 2 times interval scale data where we can for both variables calculate the averages, therefore we can use all our procedures. We can calculate the correlation coefficient, compare the means, but we can also create a cross table. And in this case, that makes sense. Very often it makes no sense with interval scale data, but in this case it makes sense, because these different procedures are like different perspectives on the same thing, on the same phenomenon. Yeah. So let's create a cross table. We click again into our data, insert a pivot table, and we want to have it again in our already existing worksheet. I need to let 3 rows place here, space. Then I can click on OK. Here we create our new pivot table. Now I want to have a cross table. So I take the correct answered questions into the rows. and I take the question no, I want to have the correct answers questions into the columns, but you can also change it. Does not really matter. So then I put I don't know much about politics into the rows, and here you see why it's a cross table, because here now the two variables are crossing each other. We will have those who said, I don't know, I strongly agree to the statement, I don't know much about politics, and who answered 0 questions correctly. Yeah. So here, for example, we have those who said, I tend to agree to the statement, and who answered 1 question correctly. And here we have those who said, I strongly disagree, but I couldn't answer any questions correctly. So those would obviously be our Dunning-Krugers. So let's see how much these are. So I put the variable from the columns into the values. So the correctly answered questions also into the values. And now again we have the sum here, and for the 0, no matter how many zeros, the sum of will always be 0. So we have to click on count. Okay, now here we have the cross table. And now in the cross table you can already see we couldn't prove the Dunning-Kruger effect with comparing the means, and also not with the correlation coefficient. But here in the cross table we can see our Dunning-Krugers, because we have those who rated 4, and here 3 people couldn't answer any question correctly. Yeah? If you think that you know much about politics and you cannot answer any of these 8 questions correctly, then maybe you overestimate your knowledge and you're a Dunning-Kruger case. Same for those who could just answer 1 out of 8 questions correctly, or 2. And I would also say those who could answer only 3 questions correctly, less than 50% of the questions. Yeah, these are Dunning-Krugers who very strongly overestimate their own knowledge. And also for those who disagreed to rated 3 and couldn't answer any question correctly, or just 1 or 2 questions correctly, I would also say these are also Dunning-Krugers who overestimate their knowledge very strongly. So what I also need to do now when we create a cross table, we need to test if the differences between these groups are significant. Yeah, we also needed to do that for our when we compare the means here. So there we would apply a t-test or an ANOVA. But I will not do that now because I want to keep the video relatively short. Yeah. Yeah, we are already at. Okay, so we are already at minute 38. So let's continue what I want to do next. So here I can see we really have some Dunning-Krugers. Now I want to differentiate. I want for everyone, for every of my participant in the survey, I want to create a Dunning-Kruger factor that should express how strong the difference is between the self-rating of political knowledge and the number of correctly answered questions. Yeah, that is what I want to do now. Therefore, I go back to the data and I create a new variable, Dunning-Kruger factor 1, and this variable I want to have first the self-rating of political knowledge. Yeah, so I click here on this cell. Minus the number of correctly answered questions. And I want to make the scale for the self-knowledge, for the self-rating for political knowledge a little bit bigger, because the scale for correctly answered questions is between 0 and 8. So I multiply the self-rating with 2, yeah, so that there we also have an 8-point scale. Now here we have, so the result is 2, so that means this is someone who has no correct answered questions, so therefore his self-rating must have been 1, because 1 multiplied with 2 minus 0 equals 2. Yeah, that is how this formula works. So let's again double click, fill in. So now we have the Dunning-Kruger factor for every person here in our survey. And the Dunning-Kruger factor should again be a value between 8. 8 would be those who couldn't answer who rated their political knowledge with 4, multiplied with 2 is 8, and then they couldn't answer any questions correctly, because 8 minus 0 is 8. Yeah, but we should also have people with a value of -7. These are those who rated their political knowledge with 1 and answered all 8 questions correctly. So 1 multiplied with 2 is 2, minus 8, no, -6. So -6 should be the lowest value in our scale. Let's see if we have done that correctly. So we again insert a pivot table. And now let's take a new worksheet. And here we want to get an overview, just a frequency table of our Dunning-Kruger factor, if that is correct. So here scale, it's from -5 to 8. So obviously no person who rated their knowledge with 1 could answer all questions correctly. Yeah, let's look into our table. Yeah, that is here. Yeah. Here we have those who rated their general knowledge with 1, and we have no one who answered all 8 questions correctly. So we have no value like -7. So now let's a little bit bigger. Let's see how many of these Dunning-Kruger factors we have. So therefore we take our variable Dunning-Kruger factor again into the value, so that we have a frequency table, and let's insert a diagram that is always a little easier to interpret. Yeah, but again I did forget, here we have still the sum, so we have to correct it into the count. And now we have the correct frequency table. Yeah, also the diagram is automatically corrected. So here we have our diagram and our frequency table. And here you see we have 3 persons with a Dunning-Kruger factor of 8. As I said, these are those who rated their political knowledge with 4 and couldn't answer any questions correctly. Here we have 11 persons with a Dunning-Kruger factor of 7. These are those who rated their general knowledge, their political knowledge with 4. 4 multiplied with 2 is 8. 8 minus 1 is 7. So these are those who could just answer 1 question correctly. Then we have a Dunning-Kruger factor like 6. That are those who rated their general knowledge with 4 and could answer 2 questions correctly, but are also those who rated their general knowledge with 3 and couldn't answer any question correctly. So also all Dunning-Krugers. Yeah. So here we have the 5. 5 are those who rated general knowledge with 4 and could answer just 3 questions correctly. Yeah, 4 multiplied with 2 is 8, minus 3 is 5. And those who rated their general knowledge with 3 and could answer just 1 question correctly. So 3 multiplied with 2 is 6, minus 1 correctly answered question would be 5. So let's assume that we will say that these with a Dunning-Kruger factor of 5, 6, 7, and 8 are our Dunning-Kruger cases in our survey. So what we want to do now is we want to create a new variable where all those who have a 5, 6, 7, or 8 will be recoded into 1. That means 1 is Dunning-Kruger, and all other values will be recoded into a 0. That means no Dunning-Kruger. Yeah. So I click again in our data set, in our data. Here I have the variable, whoops, where is it? Dunning-Kruger factor. To create a new variable, which I call it Dunning-Kruger factor 2. And therefore, first thing I need to do is I need to sort this variable. So I go on sort and filter, custom defined sort. Here I want to have the variable Dunning-Kruger factor 1. Yeah, that calculates the distance between the self-rating of political knowledge and the correct answered questions. I have clicked on data have headings, so I can say OK. And now, as I said, all those with a value lower than 5 should get a 0, and the rest 5 and higher should get a 1. So I can enter 0 here, double click in the corner, then I scroll down till I'm at 5. Whoops. 4. And here we have 5. So here, from here on, 5 and higher should get a 1. So I enter a 1, double click, and the rest of our table should be filled in. Okay, let's again have create a frequency table to see if everything went correctly. So again, I click in the table, I click on insert pivot table. I want to have an already existing worksheet, take this one. But you can also take a new sheet, that is up to you. I click on OK. And here I want now to have our new frequency table about the Dunning-Kruger factor 2. We only have zeros, that means no Dunning-Kruger, and 1, that means he is a Dunning-Kruger. So this is a nominal scaled variable, while Dunning-Kruger factor 1 was an interval scaled variable. Yeah. So, and here we see we have the sum again, so we need to change that value field settings to the count. Here we see we still have 87 Dunning-Kruger cases in our survey, yeah. And just to remind you, we couldn't show this Dunning-Kruger effect when we calculated the correlation coefficient, and we couldn't also not show it when comparing the means. But with a cross table, there we can show the Dunning-Kruger effect. So let's calculate the percentages. So I click on value field settings again, show values as, and here I want to have percentage of the whole. So we see we have 13.57% of the population. And this is a representative sample that we have here. Yeah. So we can assume that around about 13% of the population are Dunning-Kruger cases. They overestimate their political knowledge. They think that they know very lot about politics, but indeed they don't know very much about politics. Okay, so the next step now would be, and now it gets interesting, I think, from my perspective. I hope that you also find that interesting. And now it gets really interesting after we've calculated these 2 Dunning-Kruger factors. Yeah, and just have a look again into the data. Just to remind you, we have created 1 Dunning-Kruger factor where we have calculated the difference between the self-rating of political knowledge, yeah, and the number of correct answered questions. Yeah, so this is an interval scaled Dunning-Kruger factor. And then we have calculated a new Dunning-Kruger factor where we only have for those who have a Dunning-Kruger factor of 5, plus 5 or higher, they are Dunning-Kruger, they did get a 1 and all others are a 0. So all the ones are our Dunning-Kruger cases. So this is nominal scale data. So we have interval scaled and a nominal scaled Dunning-Kruger factor. And now we can use this Dunning-Kruger factor to calculate some interesting hypotheses. For example, a hypothesis that I always find interesting, usually you would think that men have a higher Dunning-Kruger factor than women. Yeah. So now you can do two things. First, you can compare the averages of the Dunning-Kruger factor 1 of men and women, but you can also create a cross table with the Dunning-Kruger factor 2. Yeah. Another interesting hypothesis, for example, would be, is there a difference in the Dunning-Kruger factor according to political worldviews? So here we can take the election intention, for example. Which party do you want to vote for? And I would have the hypothesis that the AfD and the AfD voters have the highest Dunning-Kruger factor. So again, you can first compare the means using the Dunning-Kruger factor 1, but you can also take the Dunning-Kruger factor 2 and create a cross table. And that will be your task in a moment. But I will now first investigate whether there is a difference between men and women according to the Dunning-Kruger factor. So I click into the table, anywhere, yeah, wherever, insert a new pivot table. Now I want to have a new worksheet. And here I want to compare males and females. Here we have gender, so I put gender into the rows. Yeah. And let's first compare the averages, but because I think that is the easiest way to do that. So we take the Dunning-Kruger factor 1 into the values. Here we have the sum, but we don't want to have the sum, we want to have the averages. So we click on average, and we also insert a diagram. I will also insert the data. Too many places after the comma, so double click, then click on number. Here we can click on number and OK. Close that. I have to click into the pivot table again to get my pivot table fields here. And here you see the average. There's a difference, and it's a little bit astonishing. Usually we would assume that men have a higher Dunning-Kruger factor, but here we find out that women have a higher Dunning-Kruger factor than men. Yeah, and again, just look at the difference of these two bars. It seems to be a very big difference. Indeed, women seems to have a 3 times higher Dunning-Kruger factor than men. But if you look at the numbers, that's not really true, and that is because our scale starts with 1.9, and the scale should always start with 0. So double click on the scale, and then we can here click on minimum. The minimum of the scale should always be 0. And now you see there is still women have a higher Dunning-Kruger factor, but the difference is not so big. So the question now is this difference significant? Yeah, the null hypothesis would be this difference that we observe, the observed difference, is just a coincidence. And so the null hypothesis would be there is no difference between the means of men and women, and the difference that we observe is not significant, it's just a coincidence. The alternative hypothesis would be there is a difference between men, the average for men and women, and it's significant. So we need to test this difference, yeah, and therefore we need to apply the t-test. We can apply the t-test only to 2 groups. Yeah, so only if we have 2 groups like men and women, we can compare them. So if you have the task in a moment to compare the averages of political parties, then you have to choose the numbers for 2 political parties, and you can compare these numbers with the t-test. Okay, so let's apply the t-test here. For the t-test, we can use a formula that is just equals t-test. Here it's the t-test. Yeah. And then you want to have two matrices. So these are obviously the numbers for males and females. Yeah. So before we can apply the t-test, we need to copy the two variables here into this worksheet. So we take the variable Dunning-Kruger factor 1 and the variable gender. So let's see, where do we have gender? Here we have gender. So Control C. So I copy it directly here. Control V. And then I also copy the Dunning-Kruger factor 1 we need here. This is our interval scaled Dunning-Kruger factor. And I need to copy it directly. And I need to enter the values again. Okay. So now we have our two variables here. And now to apply the t-test, we need to have the numbers for males and females. So we need first to sort our new table here. So I click into the table and click on sort and filter. And here I want to sort the variable gender. So now I have the Dunning-Kruger factors for the males, which are the 1s, and the Dunning-Kruger factors for the 2s separated. So I can apply the t-test now. So equals t-test, open the brackets. So first matrix 1 are the numbers for the males. So I have to scroll down. Here we are already at the females. It's a little bit, a little bit tricky sometimes because we have 600 data sets here, but with some training it works. So semicolon, we need to enter semicolon, and then we need to mark the variables for the females. That is our second matrix. Semicolon. So let's go back. Now he wants to know if it's a one-sided or two-sided hypothesis. And because I would propose that our null hypothesis is two-sided, that we say, so our null hypothesis would be there is no difference, and our alternative hypothesis would be there is a difference between males and females. But we would not state if the males are higher or the females are higher. If I state that the males have a higher Dunning-Kruger factor, if that is my alternative hypothesis, that would be a one-sided distribution. But in our case, we just say it's a difference. Maybe the men have a higher Dunning-Kruger factor or the women, so it's a two-sided distribution. So 2, semicolon. And now he wants to know, is it a sample with the same variance? So usually we would need to calculate the variance of the two groups and then see if the difference is significant, but we will not do it here. So we just assume that we have the same variance and we enter a 2 samples with same variance, so we enter the 2 and then we close our bracket. So we have a value, that is our p-value now. The p-value is higher than 0.05. So we observe a difference between males and females, but this difference is not significant. So we cannot refute the null hypothesis that there is no difference and that this difference that we observe is just a coincidence. And we need to assume, so we need to refute our alternative hypothesis that there is a difference and need to we cannot refute our null hypothesis that there is no difference, because this difference is not significant. Okay, now you should pause the video for some minutes and also calculate some differences between different groups in our data set. So, for example, we have questions like, for example, if you click on the variable view again, you have here the Ingelhart index. Ingelhart index is about human values, and it differentiates between materialistic values. These are those people for whom it is important to have security, to earn enough money, and so on, and post-materialistic values. These are people for them it is important to develop their own personality and to do what's right for them. And we have the 1 is post-materialistic, 4 is materialistic. The 2 would be a mixed type, which is a little bit more post-materialistic, and the 3 would be a mixed type, which is a little bit more materialistic. So, for example, you can directly compare the groups of the materialistic and the post-materialistic with each other. Yeah, that would be one task. Then you have a self-placement on the left-right spectrum. 1 is left, 10 is right. So you can examine if there are differences in the Dunning-Kruger factor between left and right persons. We have variables, for example, here the educational level. So here you have 1 would be primary education, just some years in school, and 8 would be the doctor. 7 is, I think, master, and 6 is bachelor. So these are the academic degrees. So do you think that the higher the education level is, the lower is the Dunning-Kruger factor? Yeah. But always remember that you can apply the t-test only when you compare 2 groups with each other. You can also compare, for example, voting intention, federal election, yeah, or you can compare religious or spiritual persons with each other. Okay, so pause for a moment and just try to see which group, if you compare these different groups with each other, has the highest Dunning-Kruger factor, and then also test if the differences that you can observe are really significant. Okay, so far, so now the last procedure for this video. We also want to create a cross table and to apply the chi-square test. So again, we have a look into our data. We want to see if we have more Dunning-Krugers among women than among men. Yeah, and therefore we now take the second Dunning-Kruger factor, which is nominal scaled, yeah, where we have for all those with a Dunning-Kruger factor who has a Dunning-Kruger factor higher than 5 or higher, those are our Dunning-Kruger cases. So we only have 0s and 1s in this variable. Yeah. So therefore we click into the table. We insert a new pivot table, and let's take a new table. Okay. Again, I click into the table, insert a pivot table, new worksheet, okay. So now everything seems to work. Bigger. Okay, so now we want to have a cross table, and then we want to apply the chi-square test. So we take gender first into the rows, and then we take our Dunning-Kruger factor 2 into the columns and also into the values. And here we don't want to have the sum again, we want to have the count. So here you see now that we have among men we have 46 Dunning-Kruger cases. Among women we only have 41. But we also have in our survey, in our sample, more men than women. So it's difficult to compare. Yeah, one possibility to compare these values with each other would be in a cross table if we have the percentage, how many percent of men are Dunning-Krugers and how many percent of women are Dunning-Krugers. So we go back into our data set, create a new cross table. And now I want to do that in the same worksheet. Create the cross table here. Okay. And now I want to have the same cross table but with percentages. So I take gender again into the rows and Dunning-Kruger factor 2 into the columns and into the values. I need to it's here to show the count. That is important. Don't forget that, because you will calculate wrong values if you take the sum. And now I want to have it in percentage. So again, I click on value field settings, show values as, and here calculation. And we need to take the percentages in the rows, because in the rows we want to have 100%. So all men should be 100% and all women should be 100%. Yeah, click on OK. Here now you see all men are 100% and all women are 100%. And you see 13.41% of all males are Dunning-Krugers, but 13% of 13.76% of all women. So again, a little bit more women than men. And the question again would be, is this difference significant or is it just coincidence because of our sample? Yeah. So we need to apply the chi-square test for that, to see if this difference is significant. So the null hypothesis would be there is no significant difference between males and females. And the alternative hypothesis would be there is a significant difference between males and females. And now we have to calculate the p-value again. Therefore, we need to create a third cross table. Yeah, it's a little bit complicated in Excel. It's much easier in SPSS. But we now need to create a third cross table, which should contain the expected values. Yeah, the expected values, and the expected values are those values that we would expect if there are no differences between male and female. Yeah, so let's create this cross tables. I want to have a 1 for males, a 2 for females. Then I want to have a 0 for now Dunning-Kruger and a 1 for Dunning-Kruger. I don't want to have the percentage here. I want to have standard. Oh, and okay. So 0. Okay, it works. So, so how many not Dunning-Kruger mans would we expect if there is absolutely no difference? All in all, we have 86.43% of not Dunning-Krugers in our data set. So we would expect that we have exactly this number among males and also among females. So what we do here, we calculate 86.43% multiplied with the number of males we have. And we have 343 males. 343 males. So we would expect exactly 86.43% of them are no Dunning-Krugers. So that would be number with some places after the comma. Yeah. And the same thing for females. So I take this down and then I just replace the number of males. We have 298 females in our data set. So these would be the expected numbers of males and females. And then we need to compare 297 to 296.45 and to see if this difference is significant. And I mean, we always see that. I think that is not very significant. And same thing for the Dunning-Krugers. Here we have 13.57% Dunning-Krugers. And so we would also expect to have 30.57% male Dunning-Krugers. So multiplied with 343, because that is the number of males. And then we also need to calculate expected values for the females. So here we have 298 again, 298 females, and 13.57% would be 40. So now we compare the number in the cells, 297 to 296.45, 257 to 257.56, 46 to 46.54, and 41 to 40.43. We compare these differences with each other, and from these differences, then the chi-square is calculated. Yeah. So let's now calculate the chi-square, last step for the test. So therefore we again have our formula. So we start with equals. So Excel knows now I need a formula. Here we have the chi-square test. Yeah, and you want to have here for the chi-square test the observed values and the expected values. So the observed values are these here, the values for males and females. We don't want to know how many males and females we have in our survey. We just want to have these inner fields of the of our cross table. Semicolon, and then compare them to the expected values that we have calculated here. And we can close the brackets, and that's the chi-square test. Yeah. So what is complicated about the chi-square test is just that you need to calculate this table with the expected values. Therefore, we create two cross tables, one with the absolute values, one with the relative values, and then we can calculate that. And now again, if the chi-square test calculates our p-value, we again have to see, is it lower than 0.05? Then we can refute the null hypothesis that there is no difference between males and females. If it's higher than 0.05, then we cannot refute the null hypothesis, and we can not prove our alternative hypothesis that there is a difference, a significant difference between males and females. So we have a value 0.8589. Obviously, we can not refute the null hypothesis, which does not mean that the null hypothesis is true. It just means we have not enough evidence to refute it. Okay, so that is the chi-square test. And now again, you can create some cross tables and create some hypotheses. If you look into our data set, again, for example, you can other differences between religious, spiritual, and atheistic persons according to the Dunning-Kruger factors. Yeah, you can compare the means with Dunning-Kruger factor 1, but you can also compare in a cross table and then calculate the chi-square test. Or also, if you look at the voting intention, yeah, there you can again compare the means if you use a Dunning-Kruger factor 1, or you can create a cross table and then apply the chi-square test if you take the Dunning-Kruger factor 2. So your task now is to create some hypotheses about the different groups we have here. You can also use educational level, the materialistic or post-materialistic values, and other interesting variables that have here, and see in which groups do we have the most Dunning-Kruger cases, or in which groups do we have the highest Dunning-Kruger factor. Okay, so that is a little bit when I always say that statistics is a little bit like being a detective. That is what I find extremely interesting, because again, this is a representative sample. So if you find differences, significant differences, that mean that you can generalize these differences to the whole population. Yeah. Okay, so have some fun with it. Thank you for your attention, and I hope the video is helpful. It's very long, but I hope still helpful. Ciao.